Look at function notation. So we learned that to be a function, your data for each input should have what?
One output.
Exactly one output. And so, and because of that relationship, it impacts what graphs look like, right? For example, could a function, when you graph it, could it do a loop-de-loop?
No.
No, because one input would have two outputs, wouldn't it? All right. So, because functions are kind of important, somebody came up with function notation. So let's dive right in. Okay. Oh, here we go. Here we go. Function notation. I'll just give you a preview. It looks like this. Okay, that's what function notation is. And I got a question for you. Does it make sense? Now let's think about this for a second. Does it make sense to use y for every equation?
No.
Y equals y equals y equals. For example, you might have one equation that represents one situation, but then you want to represent a slightly different situation the same way. If you call them both y equals, that could be a little confusing. So first things first, function notation. Gives the equation a name. Function notation gives the equation a name by replacing y with f of x. Or you can say it as the value of f at x. So it's a little bit more descriptive. You also will hear this called f of x. Now, here's the thing. The default is to use f of x, but how I was saying how it gives it a name, you can use g of x, you can use q of x, you can use, I guess you could use y of x if you wanted to. You can call it any other letter that you want, and it helps you to differentiate one from another. Now, here's the thing. It totally looks like I'm saying f times x, but that is not what's going on. So let's put a little star here. It is not multiplication. It is not multiplication. Also, let's go ahead and put it in here as well, that other letters can be used. Are you guys familiar with function notation? Have you guys seen this before?
No.
Oh, okay. So, let me show you an example of this. On our first example, it says evaluate f of x, or f's value at x, when x is, or when it's equal to 2x minus 7. But then they tell us some x values to use. Oh, look at this. There we go. Now we do business. So this might seem a little strange, but what you do is, to evaluate the function when x is equal to 4, you're going to write f of, guess what? 4. Because you're replacing x with 4. You'll also replace x with 4 here. And then you can simplify it.
Wait, I'm so confused, because if it's not multiplication, what do you?
You leave it alone.
What do you do with the 2 and the 4 though?
Oh, you're gonna go ahead and multiply those out.
Okay. Then why are we multiplying F and 4?
Because it's not multiplication.
Why do we need the F
It's just
though?
not, why
Alright.
do we put parentheses?
Alright, well, hold on a second. What is 8 minus 7? 1. So here's the purpose of this. Take a look at this answer. This answer tells us lots of things. It tells us that, first of all, the relationship was a function. It was a function. So we know it doesn't do loop-de-loops. We know that each input has exactly one output. So that's one bit of information this tells us when you write it this way. But it also tells us that, what was the x value that we used? We used 4 in the function, and what was our result? 1. So if we had just simply wrote y equals 1, does that tell us it was a function? No. Does it tell us what x value we used? No. So function notation is really useful. Yeah, it's kind of unfortunate that it has parentheses because we do see that as multiplication, but not when it's with, and they always use kind of weird letters. They typically avoid x and y. But yeah, so this is the value of the function at 4 is 1. Yeah.
It says negative 4, not 4.
It's 4 and negative 4.
Oh yeah, we've got both up there. Yep, they want us to do both.
both.
Yeah.
Oh, okay.
So that's the one. Now let's do it. Let's find the function's value when x is negative 4. And then on the right-hand side, you'll go ahead and multiply, get negative 8, negative 8 minus 7. So what's the function's value?
Negative 15.
Negative 15. And again, take a look at this answer. When you write things in function notation, you can easily say, oh, when we used 4, we got 1. When we used negative 4, what did we get?
Negative 15.
Negative 15. Are you guys starting to see the utility of this?
Yeah.
Why it's useful?
So you can like graph it.
Oh yeah, and you can totally graph this. Just f of x is your y value, so you'd have an x value of negative 4, and when you graph it, your y value would be negative 15.
So negative 4 would be X.
Negative 4 would be your x, and then your y value would be negative
So
15.
it's negative 4 be your input and negative 15 your output.
Exactly right. Exactly right. Okay, so here's where it gets kind of interesting. On this next example, it says let f of t be the outside temperature in degrees Fahrenheit t hours after 10 a.m. And then it says explain the meaning of each statement. Well, part A says f of 0 is 75. Well, what does that 0 represent?
Starting point.
Starting point, which was when?
10 a.m.
All right, so this would say that at 10 a.m., do you guys see how we're getting that?
Yeah.
If this is 0, that means we're at the starting point, 10 a.m. At 10 a.m., what's going on?
It's
Temperature was 75.
You got it. The temperature is 75 degrees. Degrees what?
Fahrenheit.
Fahrenheit. Okay.
Boom.
All right. This next one. What does this 3 represent?
3 hours.
3 hours after what?
10 a.m.
After 10 a.m. So what time does that put us?
1.
Yeah, exactly. So this is saying at 1 p.m., and this is kind of weird. At 1 p.m., the temperature,
Is unknown.
well, we're just going to use what they gave us there. The temperature is
N.
N, yeah,
Yeah.
N degrees Fahrenheit.
I love
Doesn't matter.
degrees
Isn't
Fahrenheit.
that silly?
It's still so nice.
That's just so silly. Okay, so let me take roll real quick, and you guys try to make sense of this last one, okay?
They said like 1 a.m. or like at 11. I just I said p.m.
I said after 11 it's hotter than the house. What do you guys think?
Oh,
I said at 11 a.m. temperature was hotter than it was at 6 p.m.
This one.
That's what I said.
She agrees.
That's a bit hotter.
But actually,
Hotter, warmer makes sense.
Yeah, exactly. I said warmer.
No, it's okay.
No, it's not.
That's
Sorry,
when
you
it was
didn't
down,
get that.
colder, 6 p.m. is starting to go down, so it's getting colder.
I know.
I mean, it could be 74 degrees, but it'll still be black.
She's your best
I mean,
friend.
I get why you would say that.
Marcel, you agree with me, right?
Okay. Ladies and gentlemen, I'm hearing some good discussion. Some people are they're talking about how you should describe it. Should you say, is it hotter, warmer,
just say
greater than? Yeah, I mean, to not take any chances, you could just say at what time?
11 a.m.
At 11 a.m., what's going on?
It is warmer. The temperature is warmer.
At 11 a.m., the temperature, because that's what F is representing, right?
Is greater.
The temperature is greater than, I should write it out.
You were wrong too.
Is greater than,
Oh my
Because you never know. What the hell?
now, you could say is warmer. Is
Oh my
warmer.
God.
You can get away with that. Is hotter. But if you're uncertain, just use the inequality symbol definition, right? So at 11 a.m., the temp is greater than what?
The temperature.
The temp at, and you guys said 6 a.m.? Is everybody,
Yeah.
I'm sorry, 6 p.m. Is everybody okay with getting that?
Yeah.
Yes. p.m. All right. What do you guys think?
It's
You
lovely.
You could
That's
probably,
exactly what I wrote.
now listen, you could probably get away with saying at 11 a.m. it's warmer than at 6 p.m. That's probably, you could probably get away with just that. Okay, so for the next example, it says g of x is equal to 1/3 x minus 2, and this is kind of different. It says find the value of x for which g of x is equal to -4. Now, a lot of people read this and they feel like it's confusing, but I would like to take that confusion away.
G of x just be -4.
It's saying g of x is equal to -4. So what can you replace all of this with?
-4.
Do it. Do it.
And don't forget.
Yeah. The g's gone because we're just gonna take this -4 and put it in place of this
Wait, how
whole
would you know
thing.
that it's a function?
Are you putting it in place? Because you just
No.
know.
Well, they told us it's a function, but now they're asking us to find the value of x. Now, how are we gonna find the value of x?
Math.
Solve it.
Solve it. Math is on.
Add negative.
What did you get?
I got -6.
Whoa.
What am I
Still
doing?
doing it. I'm waiting till they go. There's a fraction in it.
So you just multiply.
Where's -4?
I got -6.
Yeah, I got it.
How are you missing that?
Yeah, I know it's in the beginning, but we want you to have to put it one.
Oh, because you're adding the two. Okay, that makes sense.
But wouldn't you have to? Oh, wait.
Not gonna lie, I was confused on how you got -6. I was
I
like,
just
-18.
-18.
This is stupid. I
I
added
didn't read the whole thing.
if
Honors, I
give
don't think so.
you the.
Man, I don't know if I can
use the
honors,
function
man.
notation, you know it's a.
People like freaking geometry honors.
They're on these.
I got the same number.
As soon as they use f of x or g of x, you know it's a function. So there's not gonna be a
Sorry, myself.
So,
Yeah.
what's this purpose? Didn't understand.
Oh, well, the purpose is, when you get an answer, you could just list a bunch of answers and everybody will know your input and what your output was.
Okay, so for every answer you get off of this is your input.
Yeah.
So it's just giving you coordinates.
Yeah, in one little thing.
That's nice.
Yeah, it's nice.
Yeah. So that's giving you just sort
All right, ladies and gentlemen, how do you feel about this so far?
I feel good.
Good?
I
Yeah.
feel like I did one.
I just need to read the whole thing.
Okay,
Same.
next,
This looks like fun.
all right, so, next up, it says to graph the functions using a table. Well, we haven't done any graphing this year other than on number lines. How I want to introduce graphing, and you guys probably have done this in the past, but if you're graphing something you've never graphed before, what you can do is you can make a table. Now, we could call it X and Y, or we could call it X and G of X if you want. And what you could do is on the graph, mark out that Y and write G of X. But is everybody clear that G of X is just kind of replacing Y?
Mm-hmm. It's reduced this
Okay.
confusion.
It is.
Well, or it is Y. So if you're ever asked to graph something and you're not sure the shortcuts to graph it, just make a table, and it's usually a good idea to use some negative values. It's usually a good idea to use 0, and the reason why is because some weird things happen with 0. For example, can you divide something by 0? No, and so graphically some weird stuff happens when you do that. And then also it's a good idea to use some positive numbers, right? So whenever on quizzes and assessments, if I ask you to graph something using a table, I'm going to insist that you use these 5 values, okay? Now, to figure this out, what you can do is you're just going to take this -2 and place it in for X, right? Now, I don't want to clutter this up too much. Aren't we just going to do 3 minus parentheses -2?
Yeah.
Yeah.
Yes.
Oh, okay, that'd be fine.
Is it that?
So it would be 5, is that what I did?
Oh, yeah.
Add the opposites, so it's 5. And then we're going to do 3 minus -1.
And then it'd be 3.
Add the opposites, 4. 3 minus 0. 3, 4, 3 minus 1. 2, 3 minus 2, 1. And then is everybody clear that these are coordinates now that you can graph?
Yeah.
Okay.
Let me just graph it.
Mhm. Now here's the thing. Could we have used fraction amounts? Could I have chosen -1.5? -0.5 plus 0.5? Could I have chosen lots of places in between? I could have. So what we want to do is we want to infer that this pattern is likely going to do what? If I use more numbers, it's gonna keep going, right? If I go backwards, it's gonna keep going. And we can also fill in everything in between. So what I'd like for you to do is, ideally with a straight edge, I'd like for you to connect these dots. And it appears to be a line, doesn't it?
We have trouble drawing
Yeah, it's kind of tricky.
So we get the broken filter.
Oh, by the way, I suggest that you use, do you guys carry your IDs around?
Yes.
Or like a card of some sort?
Mine's right here.
My picture on that's the streetest line in my life. I'm actually
Join our class.
You can draw a line to draw.
All right, ladies and gentlemen, go on to the next one.
Mine was right, so probably makes sense.
Go on to the next one.
Oh my gosh, hold on.
What X values do we use? -2, -1, 0, 1, and 2. And, oh, we've got fractions, don't we?
Oh, boy.
This could get exciting.
No.
Yeah, I guess you could say.
All right, so, you're multiplying. So what you could do, well, first of all, a negative times a negative is gonna make what? Positive. You could think of this as 2 over 1. So when you multiply, you'd get 6 over 4, right? 6 over 4. And then, from there, you could take your 6 over 4 and subtract 4 over 4, if you wanted to have a common denominator.
2 over 4.
And so your answer would be 2 over 4, which is 1/2. So that's one way to go about this. Or you could say, oh, well, 6 over 4, that's 1/2. Make it a mixed number. Make it 1/2. And what's 1/2 minus 1? It's a half, isn't it? It's a half. So either way, you're going to get there.
I put mine.
Is everybody cool with one of those methods that I just described?
Wait,
Say what?
Anyways.
I like understand how you get there, but it's like a fraction that doesn't turn out even. It's gonna be harder to do.
Well, maybe, yeah.
So like, when I need to work it out.
Yeah, you could work
Oh, I get it. Okay,
Yeah.
I kind of understand that. That's interesting.
All right, guys, try the next one.
wait, chill out.
So -3/4 times -1.
Would it just be negative 3?
It would be positive 3/4, wouldn't it?
3/4 minus 1.
Wait, but
3/4 minus 1.
subtract
A lot of people know that right away.
Negative
Oh, so it'd be negative 1/4.
So if you need to, off to the side, 3/4 minus 1, you could rewrite 1 as 4 over 4,
Oh my gosh, what the heck, y'all?
1/4.
which gets you negative
1/4.
1/4 as a result.
Wouldn't zeros be -1?
Let's find out. -3/4 times 0.
Uh-oh.
0,
Did -1, it's
-1.
-1. Let's do -3/4 times 1
Negative.
minus 1.
Negative 1/3/4.
You got it. Yeah, that's how I would do it, is just think of it as -3/4, and then if you got minus 1, it's going to be even more negative, isn't it?
Wait a second.
Something.
And
then
that's
something.
How did you get 1 3/4?
Because it was -3/4 minus 1,
It'd be negative.
so it's
Oh,
going to be
you just
-1.
take away, okay. Yeah, that makes sense.
Wait, hold on.
Hold up. Mine's so.
No, I'm not joking, like, I'm serious, like, I don't get it.
Which one?
The
The one?
fractions, where are you getting the fractions?
Well, so what you can do, Adelaide, is you can multiply first. And when you multiply, you just multiply straight across. So for example, on
There's no like
negative 3/4 times.
reciprocaling or anything?
What's that?
There's no like reciprocal thing or nothing?
No reciprocal stuff.
So
So-
like on the bottom too, like you gotta multiply it, not just the top?
So, one, you would multiply the one with the negative 3. So you get negative 3/4. But then, Adelaide, to add this together, if you just think about it as I've got a negative 3/4 and a minus 1, they combine to make negative 1 3/4. You can do it that way, or you're gonna have to get a common denominator, aren't you?
Yeah, I guess.
So what you could do is you could rewrite 1 as 4/4. Now, why would we do that?
So you have a common denominator?
A common denominator, you got it. And then what is negative 3?
Yeah, I know that, but what had me tripping was, what's it called? That thing, what do you call it? How do you like multiply them? Like a negative 2 times 2, like I cannot multiply fractions, I can't.
Alright, so,
I don't work It's not super complicated, it's just very time consuming.
when you're multiplying fraction with the whole number, put it over 1, and you just multiply straight across.
Okay,
Straight across. And then you've
so
got
it's gonna
to,
be a mixed number.
yeah. But you can leave it as improper fraction.
I don't like it.
They're smart goggles.
They know.
Alright guys, listen up. What'd you guys get for 2?
Oh, negative.
Oh, I got negative 1/2.
What'd you get?
Negative 1/2.
Negative 1/2? Are you sure about that?
I got confidence.
I got negative 2 and
It's either that or negative 2 and 2/4.
I got negative 10 over 4. Guys, stop talking. Stop.
Oh, because this is negative. Okay.
So you get negative. This is negative 1/2 here, isn't it?
Yeah.
So you could go that route. You could say I've got negative 1/2 minus 1 means it's negative what? You got negative 1/2 minus 1, negative 2/2.
Okay, there we go.
Or you can multiply straight across to get negative 6/4 minus 4/4 is negative 10/4. But is that simplified?
No.
It's negative 5/2, which is negative 2.5. Now the reason why I like to rewrite them as a mixed number is, isn't that gonna be easier to graph?
Yeah.
Yeah, it's gonna be a little confusing if it's an improper fraction. All right, let's plot these points. Are you guys way ahead of me?
Well, I already plotted them.
Whoa. Wait, what?
Oh,
How are you supposed to put 3/4 on there?
It hurts so bad.
just estimate.
Alright.
I think I did it right.
Wait, like, so it's like before the 1 dot, right?
Sneeze like 1,000 times a day.
What's that?
It's like, if you were like gonna put like negative 3/4 on there, it'd be like,
Yes, my line is completely straight.
My circle line.
My line is very straight.
This one was
Yeah.
my handwriting is still the same as when I was in second grade.
My handwriting has changed.
I hate my handwriting. I needed to fix
Okay, I used to write my outside of the line and then a big old circle on top.
Because it's straight, it goes straight up to the line.
I'm kinda confused.
I was a little whale.
How's your writing now?
Oh gosh, you know what?
It's at 28, right?
It's right now, yep. Happy lunch.
Yay.
We get lunch, lunch runs.
You can read it, that's all that matters.
That's all that is.
My line does not look pretty at all.
My line is beautiful, I won't entirely, my line's perfectly straight on the wall,
Hi.
I have mine on my